Today we are working on lines in the coordinate plane. So the equation of a line can be written several different ways. The two that we are going to focus on today are point-slope form and slope-intercept form. Please remember that the slope of a vertical line is undefined, and because the slope of the vertical line is undefined, it cannot be written in the same format as point slope or a slope intercept. It's also not a y equals. So vertical lines equations are different than any other equation for a line. Point slope form is y minus y1 equals m times x minus x1. And m is your slope. The x1 and that y1 are your coordinates. Now notice I did not highlight the negative sign or the minus sign in front because that does not actually go with the point. So when you plug in coordinates, say 4, 3 into this, it looks like it changes sign. Our next equation for a line is slope-intercept form, and it is y equals mx plus b. Again, m is still the slope, which we talked about yesterday, and b is your y-intercept. Remember that a y-intercept as a coordinate is 0 and then your number, 0 and then b. Remember, then we have a vertical line. Remember, a vertical line has an undefined slope, meaning that it only crosses the x-axis. So our equation for a vertical line is going to be x equals a, and a is our x-intercept. So because it's only crossing the x-axis, that coordinate would look like a number and then 0. So a for our x-intercept on the 0. Horizontal line, remember, goes left to right, and that is equal to y equals our y-intercept. Again, remember, a y-intercept is 0 and then your number. Our next set of examples, we want to write the equation of each line in the given form. So when it tells you to write the equation of a line in a specific format, you leave it in that format. You don't change it to another one. Our first one, the slope of the line with a slope of 3 through 2, 1 in point slope form. So we know that we have a slope of 3. And we have a coordinate of 2, 1. And we want to write our equation in point-slope form. Remember that point-slope form is y minus y1 equals m times x minus x1. So we need to plug in our point and our slope. So y minus our y value, which is 1, equals our slope of 3, parentheses x minus our x value, which is 2. And that is our answer, because it asked for the equation in point-slope form. Our next one, the line with x-intercept of 2 and y-intercept of 3 in point-slope form. So first off, I need to know what these points are. Our x-intercept is 2, 0. Our y-intercept is 0, 3. And again, we want point-slope form, which again is still y minus y1 equals m times x minus x1. Now we don't have our slope on this one, so we need to figure out our slope. We need to calculate our slope. So we need to use those two coordinates and find our slope. Remember that slope, the formula for slope is y2 minus y1 over x2 minus x1. So that would be 3 minus 0 over 0 minus 2, which equals negative 3/2. So that is our slope. Now, it doesn't matter which of these 2 points you choose. You just have to choose one of them. I am going to use our x-intercept. So for this one, my equation would be y minus 0 equals negative 3/2 x minus 2. And again, because we want our equation in point-slope form, that is my answer. Do not change it out of that format. Next up, the line through 0, 4 and negative 1, 2 in slope-intercept form. So slope-intercept form is y equals mx plus b. And we don't have our slope, so we do need to calculate our slope. So again, remember, the formula for slope is y2 minus y1 over x2 minus x1. So to calculate our slope, 2 minus 4 over negative 1 minus 0. 2 minus 4 is negative 2. Negative 1 minus 0 is negative 1. And that reduces to 2. So I can put that in my equation. So y equals 2x plus b. Now, do we have our b? Do we have our y-intercept? Yes, as a matter of fact, we do. It's right here. Because we have 0 and then a number. So we can plug that 4 in for b. So our equation is y equals 2x plus 4. Okay, then we are going to graph our lines. And I need you to make sure that you know what your slope is and what point is given to you. On this first one, we know that our slope is 3/2, and we know our point because it's in in slope-intercept form. And our point is 0, 3 because this 3 is our y-intercept. So we're going to start by graphing that point at 0, 3. So no change on the x, up 3, and put our point. And then we're going to take our slope from there. So it's a rise of 3 and a run of 2. So we're going to go up 3 units and right 2 units. We're going to do that same thing, up 3 over 2. That puts us off the graph. So we need to go back down to our starting point and go down 3 and left 2, the opposite of what we've been doing. And you should have at least 3 points on your graph, and then connect your points. And then make sure you have an arrow at both ends to show that it's a line. The next one, we need our slope, which is -2, and then we need a point. So we need to take and look at what we have here. Every time you have an equation in point-slope form, you need to make sure that you change your sign when you're pulling out. So this x value becomes a +1, and this y value becomes a -3. Then we can take and plot that point, a +1 to the right, and -3, so down 3. And that's that point. And then we can take our slope. Now this slope means that we have a -2 over 1. So that's what we are going to do. We're going to go down 2 and right 1. Down 2, right 1, down 2, right 1. If you need to go the other direction, up 2, left 1. And again, make sure that you have a line connecting the dots. With arrows at both ends. And our last one, we have x equals 3, which means that we have a slope that is undefined, meaning that it is a vertical line, and our point is 3, 0 because it's going through 3. So we're going to graph that point, write 3 and stay there, and then we're just going to trace that grid line. And make sure you have arrows at both ends. Now we're going to compare lines. So I need you to remember that a parallel line has the same slope and different y-intercept. So m is the same, but B is different. Intersecting lines have different slopes. And coinciding lines have the same slope and y-intercept. So in other words, they are literally the exact same line. So when we're looking to compare our lines, whether they're parallel, intersect, or coincide, we need to look at their slope and their y-intercept. So this first one is already in point and slope, or in slope intercept form, and our slope is 2 and our y-intercept is 3. Second one, again, is already in slope intercept form. Our slope is 2 and our y-intercept is -1. So our slopes are the same, our y-intercepts are different. When that happens, we have parallel lines. Our next one is already in slope-intercept form. Our slope is 3. Our y-intercept is -5. Our next one is not in y-intercept form, so we need to change it. We need to subtract our 6x from both sides. So we have -2y equaling -6x plus 10, and then divide everything by -2. So we have y equals 3x plus, no, not plus, -5. So our slope is 3, and our y-intercept is a -5. So our slopes are the same, and our y-intercept is the same. When that happens, both the slope and y-intercept are the same. The lines are coinciding because they are the same line. Our next one, we need to change both of them to slope-intercept form. So subtract 3x from both sides. So we have 2y equals -3x plus 7. Divide by 2. So we have y equals -3/2 x plus 7/2, which means that our slope is -3/2 and our y-intercept is 7/2. On the second one, we still need to change it. We need to divide everything by 3. So we'd end up with y equals 4/3 x plus 7/3. And our slope is 4/3. Our y-intercept is 7/3. Our slopes, -3/2 and 4/3, are different. And when that happens, both the slopes are different, you know that you have intersecting lines.